This video is going to highlight a basic tactic for CQ and kind of talk about how CQ works, but along the way we'll talk about some other tactics that come up in the predicate logic. When approaching an argument that you're trying to prove valid, the first step never changes, and that is just taking stock. Take a look at what the argument is actually giving you and try to develop a little bit of a strategy, or at least identify some basic tactics that are going to get you some progress. And of course, part of that is identifying main operators, and when we do that, we notice immediately that line 1 is not a universal generalization. It is the negation of a universal generalization. This is important because the tilde as the main operator means that we cannot use UI. And in fact, that's one of the most basic indications that you're going to want to use CQ. Take a look at the second one, which is the version that we're going to be using here. Notice that allows us to turn a sentence whose main operator is the tilde into a sentence that is an existential generalization, which we can then instantiate. That is to say, if you take a look at that second version, essentially what's going on is that we're allowed to push or pull through the tilde. That's almost one way to visualize what's going on here. But as we do it, right, so we're pulling or pushing, the negation through the formula. But as we do it, the quantifier also gets flipped, and then the tilde shows up on the other end. Right? If we were looking at the existential version, it'd be the same thing as you push that tilde through, switch the quantifier, and then the tilde shows up on the other end. The other way to at least mechanically recognize what's going on with the change of quantifier rule is that in any situation where you've got a quantifier, so let's just use the universal for now, always think of a triple switch, just like De Morgan's, just like the mnemonic for De Morgan's back in the propositional logic. Think of 3 positions always when considering CQ. The space immediately in front of the quantifier itself, and then the space right after the quantifier. And in terms of what's happening with a triple switch is each of those positions has to change. So in this case, for example, a blank, so we've got 3 positions here. And so a blank would get a tilde. The universal quantifier would become an existential quantifier, and then the blank in the third position would get a tilde. And that, of course, is, version 1 up here. And so really to get used to what CQ looks like and recognizing it and doing it correctly, just practice that triple switch pattern or process with each of these versions. The version that we're using here is, of course, that second version. Now, what does this mean for tactics? Well, in the first place, just whenever you have sort of a mix of tildes and quantifiers, right, consider CQ. Like any replacement rule, so this goes back to the propositional logic as well, but replacement rules just give us a different look on the formulae that we already have. And so whenever you have that mix of tildes and quantifiers, think about CQ, because maybe what you need is that sentence, but with the tildes and quantifiers changed up a little bit. CQ will do that for you. In this particular case, we have a version of this tactic, which is that when you have negated generalizations, use CQ to get the generalization. Okay, so what is that going to look like here? Let's go ahead and just write that line in while we're still thinking about it. So with triple switch, we've got a tilde in front, so we'll leave it blank. The universal quantifier becomes an existential quantifier, and then because the space right after the quantifier is blank, we stick a tilde in there, and then the rest of the sentence just gets copied over. And this is going to be line 1 CQ. So again, if you see that tilde first, then quantifier, think about using CQ to get the generalization, and of course then the follow-up tactic is then instantiate that generalization. All right, but before moving on, let's finish gathering up our tactics, right? We've used this one. In this particular case, we're not going to need that one, so I'll go ahead and erase it. The next thing to notice is that After CQ, we do have an existential generalization, and so we are going to want to use EI, most likely. Right, and this is mainly because, those first 8 implication rules, we need the main operator to be whatever the rule says it needs to be. It needs to be a horseshoe or a wedge or a dot, so on and so forth. And until we strip off the quantifiers, our main operators aren't going to match those first 8 implication rules. And so typically we're going to want to instantiate any of our generalizations. Line 2 is a universal generalization. So we're going to want to UI on line 2 also to get an instance of, in this case, a horseshoe, so that maybe, again, we could use modus ponens or something. And then this is a third tactic, is whenever you're using both EI and UI in the same proof, use EI first. And this is just because of the restrictions on EI, of course. And then a final tactic that we can get just from scanning what the argument's giving us here is that our conclusion is a generalization. And so typically that's going to mean trying to derive an instance of it. For example, A is an R, and then using EG to get that generalization. Similarly, for conclusions that are universal generalizations, except with the restriction on UG, what you'd be targeting is a statement function version of the conclusion, then use UG to actually get the generalization. So in terms of predicate logic tactics, that's actually about all there is in this proof. And so let's go ahead and write these steps in and then take stock, because after we get rid of the quantifiers, then really we're just looking at those old propositional logic tactics and strategies. So as we noted here, we're going to need to EI first, and that's going to look like this. And because we have no individual constants yet in the proof, and there's no individual constant in the conclusion, then the choice of A as our instantial letter is perfectly safe for EI. We also wanted a UI on line 2. We'll do that here now. And there's basically no restrictions at all on UI, and so we're safe there. And then now really we're looking at building the proof using the same old tactics and strategies from the propositional logic. Namely, we are trying to target RA, right? That shows up in the consequent position of line 5. And so hopefully we'll be able to use modus ponens on line 5 to get that A is an R, but that means that we're going to want that A is a P. So I'm just doing a little working backwards here, right? And if we look at where we might get PA, it's clearly going to be from line 4. Of course, when you're looking at line 4, though, you're a little bit stuck because it's a negation. Outside of a horseshoe, we can't do anything directly with that, except that we know that horseshoes become wedges using implication, and that sentences that have bunches of tildes and wedges are eligible for De Morgans. And sort of more excitingly, this pattern gives us a conjunction, and we always tend to like conjunctions because we can simplify them and usually get lots of good ingredients, right? And so this is not the shortest way to do De Morgans, but I think it's the easiest way to see that we are using De Morgans. It, is the, again, kind of the De Morgans version of the triple switch. And so this tilde is getting pushed in or pushed across the embedded disjunction, which means that the erstwhile disjunct on the left gets negated. The wedge turns into a dot, and the erstwhile disjunct on the right also gets negated. Now, again, this isn't the fastest way to do this proof, but it just makes it more the most clear what's actually happening here. So let's go ahead and simplify out the half that we want and make it look like we need it to look. We wanted that in order to use modus ponens, so we go ahead and do that. That's going to be lines 5 and 9. And of course we wanted our A to use EG, which we do at line 11 to complete the proof.